Hello everyone, my name is Shankar Reddy, a second year CSE student at Keshav Memorial Institute of Technology. The project that I am working on is automated crop yield prediction. Agriculture is one of the first-born occupations in our country, India. Predicting crop yield and predicting the type of crop that can be grown in a particular soil at an early stage will help the farmer in many ways. It helps the farmer to have a brief understanding of the type of crop and the amount of yield that he can expect at the time of harvest at an early stage. This also helps him to understand the financial aspects in order to reduce losses. To predict crop yield, we need to understand the following points as well. We need to have a better relationship between the input parameters and the output parameter. A mathematical model can be developed to equate the relationship between the independent variable and the dependent variable. Secondly, we need to get time to time accurate status updates of the field to understand the strength of the soil at every growth stage. I've divided my project into multiple phases, where the first phase includes data collection process and pre-processing, which includes data from transformation, data cleaning, feature selection, etc. And in the second phase, um, I'll be working on developing a model, machine learning model, with the help of Python and famous libraries such as TensorFlow using the pre-processed data. In the third phase, I'll be deploying my model on cloud using various cloud computing platforms such as AWS, etc. And in the final phase, I'll be comparing the relationship between the predicted yield and the actual yield in order to have greater accuracy. Data collection process. The crops that I have selected are paddy, maize, cotton, groundnut, and moon, as these are the major crops that are grown in massive quantities in almost all the districts of Telangana. The data utilized in this project is collected from 32 districts of Telangana over a period of 6 years from 2014 to 2020. The input parameters include district name, year, rainfall, minimum and maximum temperature, pH value, and soil fertility. The soil fertility contains subcolumns such as nitrogen, phosphorus, potassium, zinc, copper, iron, and manganese. Data collection. I've collected data from various sources such as daysagri.gov.in for yield, and for rainfall and temperature, I referred Handbook of Weather and Climatology of Telangana. For irrigation, Telangana State Statistical Abstract. The merging of data is purely based on the attributes, district and year. This is a sample dataset which consists of one field of the entire dataset, which includes parameters such as rainfall, maximum temperature, minimum temperature, irrigation level, crop name, soil fertility, yield. Under soil fertility, we have various other columns as well. Challenges I faced during data collection. Selecting the parameters was the first challenge that I faced, as crop yield may be dependent on n number of parameters, out of which selecting the major parameters on which the yield is dependent on was a challenge. And collecting the data from various sources and trusting those sources was a challenge as well. Data was not readily available for us when the project was allotted. We Data collection process was done from scratch, where I had to go to various websites for collecting information regarding each parameter. Sources were different for each parameter, so merging of data was also different, as the data was available in other formats such as PDFs and all. I had to convert those files into Excel and then merge that data with the data with respect to the district and years. Few parameters For few parameters, data was not available in particular website. For example, when we take nitrogen values, the nitrogen values for each district was present in a different website. For example, for Adilabad the nitrogen value was available in a particular website, and for Bhadradri it was available in a different website. So collecting data for a few parameters was a task again. During data collection, the data for all the years was not available for all parameters. For example, for temperature, the data for 2018 and 19 was missing. In filling soil nutrient values, I had to compare every value with the soil map presented by central government to understand whether the value is more accurate or not. This is the snippet of the final data set, which includes 1136 rows and around 20,000 cells. Data pre-processing. First, I converted my Excel sheet into a CSV file and then imported that file into my Jupyter notebook. And then split the data with respect to season and district in order to fill the null values uh, with more efficiency. And then fill the null values with mean of particular attribute with respect to each district separately. This is a snippet of code where I've imported the data from the desktop, and this is the null values before pre-processing, where I had 260 null values in both minimum temperature and maximum temperature, and 16 null values in yield, and 142 null values in irrigation. So this is the code where I've grouped my data into two aspects, which include I've divided my data with respect to district and season. And this particular code involves filling of null value with respect to district and season. This is checking with the correlation between the parameters. Outlier handling. Outlier handling is not a very big deal for this dataset, as entire information was collected from a government source or a trusted source, and every distinct value that is present in the dataset has its own significance. After pre-processing of data, I personally perform one-hot encoding for the categorical information that is present in the dataset. And now my dataset is ready for modeling. Technology stack. In my project, I'll be using various technologies such as AWS services, which include EC2, S3, DynamoDB. And for deployment of my ML model, I'll be using SageMaker. And for developing a web application, I'll be using React.js. SageMaker. SageMaker is a platform where we can train our model, host our model, and SageMaker also provides a tool to monitor the deployed models and detect any deviations in it. And SageMaker also helps us in integration with other AWS services as well. EC2. EC2 is known as Elastic Compute Cloud. It is a web service provided by AWS, which allows us to rent virtual computers known as instances on which we can run our applications seamlessly. S3. S3 is a cloud-based storage service provided by AWS. We can also store photos, videos, etc. on S3, and those can be accessed through cloud. The region is always global in S3. DynamoDB. DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. DynamoDB is fully flexible. It is a key value and document database that allows us to store and retrieve any amount of data seamlessly. Lambda. AWS Lambda is a serverless computing service by AWS. AWS Lambda is a compute that lets you run without managing servers. It also allows us to upload code as a function and run it in response events. The function can be written in Java, Python, JavaScript, etc. Conclusion. My next step is to apply relevant ML algorithms on the pre-processed data such as random forest, Bayesian classifier, MLR, neural network, etc. After applying ML models on the pre-processed data, the model will be ready for deployment on cloud by using various other cloud computing platforms such as AWS. After this phase, I'll be working on developing a website or an app using which the farmer can avail our service to the fullest. Add-ons. Add-ons which I would like to include in my project after completing the basic project are location API. It provides live location of the user instead of the farmer giving the location manually. Weather API. It provides current weather condition and forecast of a particular location where the farmer is located at, instead of farmer giving the information regarding the weather by himself. The weather API also consists of 15 days information, which allows the farmer to get the predicted yield with more accuracy. Third one is language accessibility. As farmers in India are not very much familiar with English, we feel it is more relevant if we include a language accessibility, where the farmer can select his regional language for more understandability. Fourth one includes automatic data updation, where the data that we collected consists of 1336 rows. 1136 rows. In automatic data updation, after the harvesting of the yield, the farmer will give the information again, which includes the crop name and the yield, where the data will be again, the model will be again trained with the new data as well. In terms of making this proof of concept into a product, integrating with the government using a subscription-based model is more feasible, where the subscription includes will be providing the farmer with a handy soil testing kit, which provides us the information regarding the nutrient values, which helps the farmer in many ways, where There is no a need for the farmer to visit the lab for testing of soil, as the machine, the handy kit will give faster results. Thank you.